Okay, inscribed angles. This orange is an inscribed angle. We know it's an inscribed angle because the vertex is on the circle. This orange is the inscribed angle. The blue is the intercepted arc. Moving along, inscribed polygons. It's all the vertices on the polygon lie on the circle. This triangle is an inscribed polygon because these points lie on the circle. The circumscribed circle is the circle that contains those points of the inscribed polygon. So this is the circumscribed circle. This is the inscribed polygon. New theorem. The measure of an inscribed angle is half the measure of the intercepted arc. Looking at my picture, this angle is half of this arc. This arc is double this angle. That's where both of these come from. You could use either one of those depending on the situation. Looking at the first example, it asks us to find the measurement of ST, which is from here to here. We know that this is a diameter because it goes through the center. So SU is a diameter. Because it's a diameter, this whole arc has to add to 180. We're already given that the inscribed angle is 61. You double that using my theorem, which tells me that this arc is 122. So when we subtract 180 from 122, what does that give me?
58.
58.
I'm so smart.
Because these two angles have to add to 180 because this is a diameter. Moving on to my second example. So we're asked to find VST, this arc. We're given part of it as 39 degrees. We have an inscribed angle. So I would start, well, there's lots of different ways you can do this. If this inscribed angle is 51, what does this angle have to, this arc have to be?
102.
102. We're doubling it. So now we can do this a couple of different ways. I think the simplest way to do this is to take this part, that arc, and subtract from 360. We know that this is 102. We know this arc is 135. If we add these two together and subtract from 360, that would give me the arc that I want. So someone do this for me. So we need 360 minus 135 minus 102. What does that give me? What's that give me? 123. 123?
As VST. Yeah.
From this whole angle. Not the only way to do it, but I think that's the fastest way to do it. Moving on, the next one asks you to find the measurement of arc AB. So what we start with is what's given to us. This angle is an inscribed angle. So if this angle is 20, that means that arc BC is double that, which is 40 degrees. I also see on this one that this is a diameter because it goes through the center. So if I know that this part of the arc is 40, what does this part of the arc have to be?
140.
140 to add to 180. Looking at the next example, they ask you to find the measurement of angle JLM. So this is the angle that we're looking for. Several ways you can look at this one too. Remember, this also has central angles in it. So what I see this is 88. So this arc has to be 88. Remember, central angles and their intercepted arcs are the same. This is 88 because of vertical angles, which means this arc is also 88. Who can tell me what this angle would have to be?
92.
90? Why 90?
92.
Okay. This is a straight line, so this 88 angle and this blue angle have to add up to 180. So because that one's 88, this one gives me 92. If that's 92, then this arc is 92. You following where I'm going with this? So this arc is going to be the leftover. So if I do 360 minus 88 minus 92 minus 88, it's not the only way to do it. What do I have left?
Oh,
Anna?
268.
2 what?
68.
That doesn't sound right.
Or
92?
No, 360 minus 88 minus 92 minus 88. I want the leftover right here.
92.
Because these two angles are going to be vertical, which means this one has to be 92 also. Okay, now we have the opposite of what we did a minute ago. This arc is 92, so what does this angle have to be? Half. Half.
46.
There you go. So that angle has to be 46 degrees. There's lots of back and forth with that kind of problem. Another new theorem says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So we can say it can be written where all the vertices are on the circle if the opposite angles add to 180. So looking at my picture, angle A and angle C have to add to 180. Angle B and angle D have to add to 180. So looking at my example, it says find X and Y. So because it is drawn inside the circle and the vertices are on the circle, we're going to say this and this angle have to add to 180. So if you want to set up an equation, if it's a harder problem, X plus 108 equals 180. So what's X?
72.
72. Y, they're opposite one another. They're marked as the same. So we can say Y plus Y equals 180. So what's Y have to be?
90.
90. These problems are usually relatively simple, but understand how to set them up just in case they're harder kind of problems. What's the relationship between this inscribed angle and this intercepted arc? What would my equation be?
5x times 2 equals 9x plus 21.
So 2 of these angles gives you one of those arcs. You could also say half of this arc equals 1